my dear students. So today we can start with differentiability. Okay. So first of all, what is differentiation? Differentiation means just rate of change of a function. You have heard in physics, I think, rate of change of distance, rate of change of speed, like that. Okay. So we can just keep in mind what is differentiation means. It's rate of change of a function. Okay, rate of change of a function is just differentiation. Then we need to differentiate if the function is not constant. So we need to know what is a constant function and what is not constant. Okay, so just imagine you are driving a car and you are not changing the speed. At around 60 km/h it is constant. For hours you are not changing. Okay, such functions are called constant functions. That means I will show in a graph. If this is a time and here if we plot distance, time in 1 hour, 2 hour, 3 hour, you are at 60 km. Again 60, 120, again 60, 180, correct? So at 1 hour you are 60 km. Again it is not changing in the second hour. Again in the third hour, again 60 km/h. So you are getting a straight line. Such functions are called constant function. No need to differentiate such functions which is not constant. For example, if you are throwing a ball, initially positive velocity will go. Once it keeps 0, it will fall down, the velocity become negative. Such functions are called not constant, correct? It's going up, then down. Where velocity is increasing, then decreasing. You know what is velocity? Rate of change of speed, correct? So this function, we can differentiate such functions. That is just an introduction about differentiation. So we can check how we can denote differentiation notations. Okay. So students, if y equal to f of x is a function, what are the notations of differentiation? First, we can denote f dash of x is one type notation. That is, differentiating this function, we can denote it as f dash of x. Okay. Other thing, y dash is also another notation. Then another thing, we can d by dx of f of x we can write. Directly you can write otherwise dy by dx. Usually this is commonly we use. Okay, dy by dx. This four notations you can use. Basically we will follow dy by dx. This is a notation for differentiation. Okay, so some formulas first we can study so that we can enter to differentiation. So students, first we can check what is the derivative of d by dx of a constant value. Okay, d by dx of a constant value is always 0. Okay, here that is example, d by dx of 2. That is actually what? 0. For constant value is 0. Next thing, d by dx of x raised to n is actually nx raised to n minus 1. That means, example I will show, d by dx of x cube means, here in the place of n we have 3. So here nx raised to n minus 1, just substitute. 3x raised to 3 minus 1 is 2. That is 3x square. It is the derivative of x cube. Clear, students? Next, we have d by dx of e raised to x. That is same. There is no change. E raised to x itself. Okay. Then next, d by dx of log x with base e. That will be 1 by x. Clear? Then next, then we have d by dx of sin x. Okay, trigonometric function. d by dx of sin x is cos x. Okay, then d by dx of cos x will be what? It will be minus sin x, okay. There will be a negative sign, you should remember. Then what? D by dx of, we have tan x. It is sec square x. Okay. Then d by dx of sec x will be what? It will be sec x tan x. Okay. These are some basic formulas. You have to study these formulas in order to move to solve the problems. Okay. Then next I will show some algebra of derivatives. Okay. So next is algebra of derivatives. That is, first u plus o minus v whole dash. If two separate terms, either addition or subtraction, separately we can find out the derivatives. Okay, that is, first derivative of u you find out, then add or subtract, then find out the derivative of v. Separately we can solve. Okay. Next, if it is product uv whole dash, then first you differentiate u dash, then v as such, plus v, then v dash u. Okay, that is first derivative, then v as such, plus then derivative of v, then u as such. It is known as product rule. Then next we have quotient rule, that is u by v the whole dash. Means you can first find the derivative of v, u, then keep v as such. Here minus sign is there. Then v dash u by, we have v square. This also you should keep in mind. That is the algebra of derivatives. Here product rule and quotient rule is very important because it is little confusing. In product rule we have plus sign. In quotient rule we have minus sign. Okay. Also there is a denominator in quotient rule. Here first you can find the derivative of u, then place v as such, plus then find the derivative of second u as such. Then we can do some problems. So students, first we can do with chain rule. Okay, there is chain rule, there is formulas are there, but I am directly teaching how to do with the chain rule. So the problem, we can directly move to the problem. The problem is y is given as tan of 2x plus 3. This we need to differentiate. That is, we need to find what? dy by dx, that is derivative of y. We know the formula of what? d by dx of tan x we have studied. It is what? Sec square x. This formula we have already studied. Okay. d by dx of tan x is sec square x. This term you assume it as x. In the place of x, substitute 2x plus 3. Okay. That is tan of this, tan in the place of tan x what? Sec square. In the place of x you substitute 2x plus 3. Chain rule, it is called chain rule. Then you put a into sign. It is not completed yet. Now we need to differentiate the bracket. That is, in bracket we have 2x. That means d by dx of, we have studied x. X raised to n we have studied. That is n x raised to n minus 1. Here in the place of n we have 1. That is 1 x raised to 1 minus 1. That is 1 x raised to 0. That is what? 1. So differentiating x you will get 1. 2 as such you can write. 2 into 1. One more term is the plus 3. 3 is what? Constant. Derivative of a constant is 0. So plus 0 in the bracket, this is the derivative. So arrange it and write. Okay, sec square 2x plus 3. We have what? Only 2 remains there. So we have here 2 sec square 2x plus 3 is the answer. Chain rule means you multiply and write. The bracket you expand it using multiplication, that's all. One more problem we can look. Okay. So the next question is, sine of cos of x square. Here bracket is increased, correct? So how you can differentiate using chain rule? So this is y actually, okay. So dy by dx is, we know that sine x is what? Dy by dx of sine x we have studied as cos x. Clear? So in the place of x, substitute this thing. In the place of this x, substitute what things in the bracket. So sine of x means cos x. That is cos of, in the place of x we are going to substitute what all things in the bracket. Clear? First step over. Then into, okay, into, inside the bracket we are going to find. That is cos of x square. We know that. D by dx of cos x we know, which is known as minus sin x. So minus sine of, in the place of x we have x square. Into, again we have to differentiate x square. X square means what? X raised to n. N x raised to n minus 1. 2x raised to 2 minus 1. 2x. Okay. That is 2x. Finished. Now anything left? No. So now you can rearrange and write. 2x first you can write. Minus sign is there here. Then sine of x square you can write. Cos of cos x square last you can write. Okay. So this is the answer of derivative finding using chain rule. Clear, students? So next class we can do more problems with more formulas. Okay. So till then keep practicing. Bye.